This video provides a demonstration of the technology in use in Bluelock's Recovery as a Service solution. Recovery as a Service, or RaaS, enables organizations to recover their IT resources efficiently and effectively when an adverse situation strikes, preventing loss of revenue, data, or reputation. Bluelock offers two recovery solutions, 2-Cloud RaaS and In-Cloud RaaS. 2-Cloud RaaS allows you to recover applications from your own data center to Bluelock, while In-Cloud RaaS allows you to recover your applications from your Bluelock Virtual Datacenter to another Bluelock facility. This video demonstrates setup and testing of Zerto as it powers our 2-Cloud RaaS solution. What we're looking at here is the client's Virtual Center view. This is the view that the client will see at their site. You can see on the left side of the screen in the VM tree that there is a production app, SQL, and web server. You'll also notice that it has a Zerto tab added to the right side of the tab menu. The Zerto tab provides access to replication and recovery controls, which we'll review later. Now let's jump over to the target site. This is the Bluelock site, the vCloud Director Zone. You can see here in the Recovery Virtual Data Center, which is a 4000 series data center, that there are no vApps or VMs defined. This is simply an empty target virtual data center. If we select the Administration tab, you'll see that there are networks that are pre-created. These can be your internet-connected networks, your private isolated networks, or any other DMZs your workload requires. These networks will be used to assign networks to your VMs during the automation workflow that takes place when you initiate recovery. VMs are predefined to connect to these networks, eliminating error at time of recovery. Now let's create a virtual protection group. A VPG, or Virtual Protection Group, is a group of machines that are protected in sync together. To create a new VPG, select the Zerto tab in vSphere on the client site. When you click the New VPG button, it will ask you to specify the target site for recovery. We selected Bluelock. In the Manage VPG window, you can give your VPG a name. We'll call ours Prod Application. We're choosing what VDC at the target site we're going to use. In this example, it's Customer B Paygo. We're also choosing what networks we want to recover virtual machines onto, as seen previously in vCloud Director. Clicking Add allows us to view a list of virtual machines from your vSphere view and add VMs that we mentioned before, the production app, SQL, and web servers. They will then appear on the VPG's VM list. Clicking Save creates the virtual protection group and begins synchronization. You can see that there is an initial synchronization that has to occur. You can also see statistics on this synchronization, such as WAN traffic speed and replication speed. Digging into the application further, you can see the specifics for this VPG. You can see the production application's initial sync is 3.1% finished, an estimated completion time of around 18 minutes, and throughput performance and WAN traffic utilization. Once the initial VPG sync is complete, you can see arrows on the GUI to indicate that replication is occurring from the customer site to the recovery site. You can also see that there are multiple VMs and VPGs. On the failover button, you'll notice that the test option is selected by default to indicate that we are in a test recovery, not a failover. When we select the failover button, you will see this instance is called a test failover, so you know that this is a test. After checking your selected VPG, you're prompted for the checkpoint to which you want to recover. We'll choose the latest synchronization and then click the failover button. This demonstrates how simple it is to execute a declaration or test from a technology standpoint. This will now start the workflow and automation behind the scenes to start up the vApps and VMs, booting them up in a predefined order and ensuring that they're running in the virtual data center target. You can also monitor the status of your failover test and workflow progress within the vSphere window. In this case, we see that the failover test has started and that it is 5% through the workflow. Now let's view the test progress from within vCloud Director. From the vCloud Director view, you can now see that there is a production application vApp in the vApp listing that houses the virtual machines that you've chosen. This vApp is currently stopped and at this moment does not show any VMs, but the automation is working in the background. If we select the Virtual Machine tab for this vApp, we can see that there's already another one pending creation. Refreshing the view reveals all 3 production VMs. They're powered off currently, but it's going through the process of powering them on, and they will be running and functional in moments. Now we're going to go through the process of cleaning up after the test. In vSphere on the client side, we can see on the Zerto tab that the test is in progress based on that checkpoint selected. We're going to stop this test by clicking the stop icon and confirming this action. This will stop that particular test, begin the cleanout process, and revert all of the VMs out of vCloud Director so that you have an empty virtual data center. Not to worry, all the data and replication checkpoints remain and have continued replicating behind the scenes during the test, meaning that the RPO was never compromised. Switching over to the vCloud Director view, you can now see that your data center is clean. The VMs have continued to replicate the entire time, and they are cleared out of the vCloud Director Virtual Data Center in a fashion that readies it for another test or declaration.